So would you get out the paper that you have called Graph Practice 1? It's one of the ones I gave you the other day. It's called Graph Practice. It's only got a couple pages to it. Everybody got one. Don't be saying you didn't. Next time, please take a picture of somebody. And the quiz we take tomorrow is going to look exactly like this, only it's just one side. It's just one side, just like this. So somewhere on the page is going to be some kind of weird shape that I have just randomly made up. So in this case, our random weird shape is this. And I want to make sure that I got a good grip on what this thing looks like, because I'm going to be reproducing it for all the rest of my problems. So every picture that I draw on my quiz tomorrow is going to be based on whatever picture that I give you. So this is the one we're using. So number 1 says f of 1/2 x. So using the picture, what do you think is going to change? Take a look at that number. It's going to change the width. This number right here divides the width. So you are dividing by 1/2, which is the same as, thank you, timesing by 2. So you're going to redraw this picture, and I would do it shape by shape. So maybe start with this trapezoid, and it's going to be twice as wide. Now in the original, it's 1, 2, 3, 4 wide. That means when I redraw it over here, it's going to be 8 wide. So it may go off your graph. I don't know, get creative, do the best you can. 1, 2, 3, 4, 5, 6, 7, 8. So it's still down 1. And every dot is twice as far apart as it was in the beginning. So there it is. That's actually supposed to be straight across there. Now, how about this triangle? Well, it too is 1, 2, 3, 4 across. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. And still up 3. We haven't changed the height at all. Other numbers change the height. That 1/2 just divides the width. And then we got our little triangle. It's 2 across, but now it's going to be 4. So there we go. And you've drawn that the best you can in the space that you've been provided. If it had to come off the page over here, that's okay. All right, so what do we need to remember? Because the shape we get tomorrow is going to be different. We're probably not going to have that exact problem, this exact numbers here. What do we need to remember? That when we put a coefficient on x, it divides the width. That's what you got to remember. It divides the width. All right, problem 2. What's happening in this one? 2 things are happening. So first of all, Tanner says it flips it. He's going like this, upside down.
And then it goes up 1.
So this is upside down. And this is up 1, right? So here we go. I'm going to do this in 2 steps. Feel free tomorrow to bring a colored pencil, a highlighter, something, if you want to do your problems in more than 1 step. So I'm going to first of all go upside down. Remember, we try to follow the rules of PEMDAS. So this is like a multiplication here, timesing by -1. So we're going to do that before we add 1. So I'm going to take my original, And 1, 2, 3, 4, turn it upside down. There it is, turned upside down. Everybody okay with that? Now I'm going to take that exact picture and move it up one. So every point goes up one. So I'm going to get my purple marker. Every point goes up one. So there's my trapezoid. Here's my triangle, my big triangle. And then here is my little triangle. And so my answer is the purple. Everybody okay with that? So again, you're not going to see that exact problem on the quiz. You just need to remember that if there's a negative out in front, we're going to go upside down across the x-axis. And if there is a plus or a minus stuck on the end of the problem, that picks us up or picks us down, right? All right, number 3. What's going on in problem number 3? What?
Is it getting moved left?
It's getting moved left one. That's exactly right, James Wayne. It's getting moved left one. So you're going to take the original picture and you're going to just shift everything left one. So that means my trapezoid that used to start here at the origin, it now is going to come over to here. Starts over 1. My triangle is still 4 wide and 3 high, but it's shifted over. And my little triangle kind of follows along. Is that okay with everybody? Left one. Number 4. Got another negative in here. We know negatives always do what? Negatives have one function. They flip one way or the other, right? Where does this one go? Across Y. Okay? So here we go. We're going to go across the Y-axis, back to the original. That means everything that was on the left is now going to get drawn on the right. And everything that was on the right is now on the left. There it is. Everybody good? So what do we need to remember? We absolutely need to remember that a negative on the x is going to flip you sideways, whatever shape you have. Ooh, 5 is new stuff. I mean, really new stuff. Last thing we talked about last time. Okay, now that's the absolute value of the whole shebang. Okay, that's everything, absolute value. So what impact does that have on our original graph? Everything below goes up. Everything that's already up stays up, but everything below goes up. So that trapezoid that had been drawn down is now going to be drawn up. There's my trapezoid, drawn up. The big triangle is just the same. He's already up, he stays up, but the baby triangle comes up. Remember, when you do the absolute value of the whole thing, everything from the bottom flips up. That is very different than the next problem, which is this. That is not the absolute value of the whole thing. That is the absolute value of just x. Who remembers what we do when we have the absolute value of just x? What?
You just keep the one side.
You just keep, which side do I keep? Right side. I keep the right side. So I redraw the right side because this is where the positive x's are. This is where the positive x's are. So I keep the right side. So I redraw the right side exactly as it is. Do not change a thing. There is the right side of my picture. Then what do? Copy it onto the left side. Now some of you are thinking, well, wait a minute, what happens to the trapezoid? He's gone. He's gone. The left side disappears and it's replaced by the right side.
It's always if it's like that.
What?
Always if it's like that.
If it's the absolute value of x, you draw the right side and reproduce it on the left side. All right, and then what about number 7? It's going to be this picture, right? You're going to reproduce that picture and then drop it down 1. So you're just going to redraw that again and then drop everything down 1. So number 6 is my black line and number 7 is my purple line. So I was kind of lazy and didn't redraw it. I put them both on there. So number 6 is the black, and number 7 is the purple. You good with that?
So on our quiz, you want us to just put the left side up, or you want us to put the bottom?
Yeah, that is the answer.
Okay.
Anything less than that is not going to be the answer. Now the quiz is only going to have, like I said, one side. But we got plenty of practice on the back. So let's do a few more of these practice, and then we'll get back to our notes. Okay, Andy, does that sound like a good idea? Yes, Mrs. Ford, I can't wait to do the back side. Here we go. Number 8, we're going to use the same basic picture. And now we're going to sketch 2f of x minus 1. So what do we do with the 2?
Stretch it out.
Stretch it up, right? That means my picture is going to be twice as tall. This multiplies the height. That number multiplies the height. Remember, when you put a number inside, that number divides the width. So remember, a number out in front is a multiplier. A number inside is actually a divider. So I'm going to have this exact picture, but everything's twice as tall. So my trapezoid, instead of going down 1, is actually going to go down 2. It's going to be exactly the same width. It's just going to go down 2. My triangle, instead of going up 3, is going to go up 6. And my baby triangle is going to go down 2. But I'm not done, am I? What still needs to be done? Down 1. So now I'll take my colored pencil or my highlighter or something, and I'll drop everything down. Just 1. Just 1. So the blue thing is my answer. Now we have hit everything, all of the different numbers and negatives and everything. So look at the rest of what's on the page there, 9 through 15. And are there any of those you'd like to do?
I have a question for 11.
11? We can do 11.
Down and then stretch it like this.
There are 3 things happening in 11.
Shrink it, right?
Can you tell me what the 3 things are that are happening in problem 11? So this is going to make it go upside down.
Yeah, and then you stretch it out.
This is going to be height times 3, right? Height's multiplied by 3. And then I'm going to go up 1. Now you need to do this in as many steps as you want. You can do it in 3 steps if you need 3 steps. I think I can actually flip it over and make it 3 times as tall in 1 step. So I'm going to do that part first. I'm going to flip it over and make it 3 times as tall. So that means, back here to the original, the trapezoid is going, flipping up, and instead of being 1 tall, it's going to be 3 tall. So I'm going to flip my trapezoid up. And there it is. There's my trapezoid flipped up. Same width as before, 4 across, but now 3 up. The big triangle is going down. And since originally it was 3 tall, it's now going to be 9. So it may run into the picture below it, that's okay. So it's still only 4 wide, so it's pretty skinny. It's pretty skinny. And then this baby triangle is going to flip up, and it's going to be 3 tall. Now we're not done. This is what you got to be careful of. Yeah, you got to be careful that when you do it in stages, you don't forget to finish it. That took care of this part, right? So now I still need to take the whole shebang and lift it up 1. So everything is going up 1. Whoever's binging, please turn the binging on. There we go. Does that take care of your question? All right, anybody else see one on there that we need to talk about? James? 12. 12, it has 2 negatives in it. So if it has 2 negatives, that means we're going to have to flip both directions. And the order that you flip does not matter. So do whichever one you want to do first. It really makes absolutely no difference. You got to do both. It's probably kind of hard to do both at once. Some of you might be able to do it. I think I'm just going to do one at a time. So James Wayne, which way do you want to flip first?
X.
So this, this way, up and down?
Up and down.
Okay, so if we're gonna flip up and down, that means that our big triangle's coming down, little triangle's going up, and trapezoid is going up. So that's the negative F part. We've done the negative F part. Now we have to do the negative X part, which means flipping it this way. Now, all right, so I'm gonna flip it this way. So that means this guy is coming over here. So I'm gonna go ahead and erase him. I got him over here. The big triangle is coming over here. Get rid of him. And the baby triangle is also coming over here. Okay, wait a second. So James, does that make sense to you? Okay with that? All right. So would what?
15, like, flip it across the.
No, 15 does no flipping.
Oh, it's
15 is f of x, which is this guy right here, and down 2.
okay.
The only thing that's happening in 15 is you're going down 2.
And then, same, what about 14?
14 is going right 2.
Okay.
There's no change except for right 2. All right, so we're all clear on what the quiz tomorrow is going to look like, right? Okay, let me hand back last time's quiz.
No, it's just not.
These were worth 9 points.
I was like, what?
Pass them down to the right person. All right, when you get your paper back, if you miss something, let's take a look at it and see if we can figure out why you missed it. There's Stephanie's. And
I need to do better than my grades.
Anything we need to talk about on these quizzes, or are we good to go? All right, is there anything we need to talk about on that?
Is it out of 9?
Yes. All right, let's get our notes back out then. Yep.
I never took this. Are you going to have any
Yes, sweetheart, you're supposed to come in and next morning and take the quiz.
I know, but then I wasn't here.
You were here this morning. Okay, so did I eventually get rid of the ones there? No. So did you eventually all get there then this morning? Okay, so we're back on our notes now. We have one more section. So we'll be having a test, the first part of the next week probably. One last test before the end of the quarter. Now, I have no idea how many other tests you're gonna have. So we're getting close. So start planning ahead. We'll do our practice tests. But I don't want you getting all overwhelmed and all that stuff. But it's time for a test soon. All right, so the only thing we have left is 1.7. And this is word problems, our very favorite. I'm giving you a heads up that we are absolutely going to have our graphing calculators with us. There is one question in particular where you have to have a grapher. Since that is the required calculator for the class, that is the only calculator you'll be using. And you will need to do operations, just arithmetic with the calculator. So, let's get in the habit of bringing our calculator. Okay, but we don't need it for question number 1A. Write an expression for 6 more than twice a number. Exactly. We're on page 13, down at the bottom, 1.7. It says 6 more than twice a number. 6 more than twice a number would be 6 plus 2x or 2x plus 6.
Yep.
Now be careful on the next one. 6 less than 4 times a number. Exactly, 4x minus 6. Now, on question number 1, you could write it 6 plus 2x or 2x plus 6. It doesn't make any difference on question number 1. On question number 2, it makes a difference. If you turn this around, it's wrong. When we say 6 less than something, don't we mean take away 6? If I said, you weigh 6 pounds less than me, it's not 6 minus my weight, it's my weight minus 6, right? So 6 less than means minus 6. If you do it in the other order, you're going to miss the problem. All right, here we go. Next. 24% of a number. Oh my gosh, I feel like I'm in first year algebra. 24% of a number. How do I do that? 0.24 times x. Remember in mathematics, the word of means times. So 24% of a number means 24 times, or 0.24 times the number. Percent, 2 decimal places, right? The final cost of an item, if the original price is X and there is a 15% discount and a 7% tax. Now, what are you doing on that iPad over there? Huh?
It's not on.
You were typing on it.
Yeah, he put the thing right on.
We're going to do things a little bit differently than maybe you did when you were in first year algebra class. We're going to think about doing the entire problem, problem D, in one big operation instead of doing it like you did when you were younger. When you were younger, if there's a 15% discount, you multiplied whatever it was by 0.15 and subtracted it. Remember doing that? And then if there's a 7% tax, you would take whatever you had then, multiply it by 0.07, and then add that on. So basically that problem involved 2 multiplications and an addition and a subtraction, right? And that will always work. It's going to be easier on us, especially when we get to our sequences and series, if we get in the habit of doing it as one multiplication problem. Here's what I mean. If we are going to take a 15% discount, pretend you're going into the store and you're going to buy something for 15% off. You don't really care how much you're saving. What you really want to know is how much it's going to cost you, right? So if they're going to take off 15%, then what are you really paying? 85% of what it was originally. So if we have a 15% discount, I'm going to get another marker, a 15% discount, then we're going to represent that by 8.85 times the cost, whatever it is. So instead of taking 15% of the price and then subtracting it, we're just gonna multiply by 85%. Because if the store is taking off 15%, you're gonna still pay 85. Would you agree? Now, I'm gonna take that amount, whatever that is, and I am going to add on a 7% tax. I'm not gonna multiply by 0.07 and then add. I'm gonna multiply it by 1.07. That is exactly right. Kids, if there is a discount, you're taking the 100% price and subtracting off the discount. That's how I got 0.85. If I am adding on a tax, then I'm going to take the original 100% and add on another 1.07. So now instead of doing all those steps, I'm doing one multiplication. I'm taking whatever the price is. Let's say I want to buy a new jumper and it's $5, okay? I would multiply $5 times 0.85 and then times 1.07, right? And that would give me the answer to the question. We're going to do some of those, so hang on to that thought.
So even if it was 9%, it'd be 1.09.
If it were 9% tax, you mean, you multiply by 1.09. So in fact, let's look at E. My boss is going to give me a raise, okay? So one way I could calculate my new salary is to take my salary, multiply it by 0.07, and then add it. I don't want to do that. I want to do it in one step. So I can find a 7% raise by taking my salary and doing what? Multiplying it by 1.07. If you're adding on a tax, a raise, a commission, if you're adding on, you take 100%, one, and add on whatever percentage you're doing. So if I'm adding on 7%, I multiply by 1.07. If I am taking away, like a discount, a sale price, then it's 1 minus. So if I had a 7% discount, or if my boss said, I'm cutting your pay 7%, then I would multiply by 0.93. We either multiply by 1 plus the percent, or we multiply by 1 minus the percent, depending on if the situation is an add-on or a subtract off. All right, the area of a rectangle whose width is 3 less than its length. So I'm going to draw a picture of this. There's a rectangle, and the width is 3 less than the length. So what would be a way? There's lots of ways. What would be a way to describe that if the width is 3 less than the length? What? I heard somebody say x minus 3. Well, then you're saying this is going to be x, and then this will be x minus 3? Will that work? Absolutely. That's one way of doing it. If you set it up that way, the question says write an expression for the area. How do we find the area of a rectangle? Length times width. So x times x minus 3. So there would be other ways that you could set this problem up, but does that make sense to everybody? The width is 3 less than the length. Now we have another rectangle. The perimeter, we are find an equation or expression for the perimeter. The length is twice the width. The length is twice the width. So what's that going to look like? X and 2x? That's one way of setting it up. It's a beautiful way. Now we want perimeter, not area. So if you want perimeter, that means you're going all the way around, right? So you add all those up. So x plus 2x plus x plus 2x. So my answer would be 6x. And finally, another discount problem. Find the final cost of an item whose original price is x. So there's x. We're going to have a 20% discount. So what am I going to multiply it by if there's a 20% discount? 80%, 0.80 or 0.8, 80%. But then I have to pay 7% tax. So what am I going to multiply it by? 1.07. Remember, discounts come off. So this is going to be 1 minus 20. And this is going to be 1 plus 7%. Discounts come off, minus, taxes add on. Everyone good with that?
That 0.24 actually is another problem.
No, that's another problem. You can erase it. All right, now we need our calculators because now we're actually going to do some problems. Your favorite teacher received a 3.2% salary increase. If her original salary was 1, 2, 3, 4, 5, find the new salary. So what are we going to do? By the way, that's just about twice what my first year salary was at Precal C. Huh?
That's so little.
Yeah, tell me about it. And I was so proud. My husband's got a picture of me with my first paycheck. Back then we actually got paychecks, now it's just all wherever out there in space somewhere. But he's got a picture of me standing there like this with my first paycheck. It was like $12 or something. It was awful. But anyhow, all right, so what am I going to do? How am I going to find the answer to this question? I'm going to take 1, 2, 3, 4, 5, and I'm going to do what with it? Multiply it by 1.032, and that's going to be the answer. So 1, 2, 3, 4, 5 times 1.032. And the new salary is $12,740.04. Everybody okay with that? All right. Now we've got a review problem from first year algebra. And I taught some first year algebra this summer, so I know this is a first year algebra question. So let's review how we find percent of change. So it can be increase or decrease. This one happens to be an increase, but it could be decrease or increase. Anybody happen to remember from first year algebra how you find the percent of change?
Let's just take like the 89.50 multiply by x equals 7.75.
To find percent of change, what we do is take the difference and divide it by the original. So I'm trying to think how that meshes with what you said. We got to have the difference in there. So the difference of the two values divided by the original value. So we're going to take 97.75 minus 89.50. That's going to be the difference of the two values. And we're going to divide it by the original price, which would be which one? The 89. And that is going to give us our answer. By the way, if you're planning to type it in exactly like I wrote it, make sure you either put this in parentheses or hit equals before you hit divided by. You need to have that difference before you divide. And I got a 9.2% increase. Is that what you got? .2? Yes, ma'am.
When I divided 97.75 divided by 89.50, I got 1.092. So then if you just
So that means, I think that's maybe what you were talking about. That means that this number is 109.2% of this number. That'll work.
is it the same thing what we do with the 1.07 like the tax, you put the 1, so that's what the 1.
Yes, yes, it means it's 100, yes. If you multiply the original value by 109%, you would get this. Yep. All right, letter C. So one way or the other, see if you can find the percent of decrease. This is exactly the same thing, only the numbers are going down instead of coming up. So see if you can find the amount of decrease. Oops. What'd you come up with as the amounts of decrease? 20%, basically 20%? Did you get 19.99999 or something like that? Now, if you did it Olivia's way, what did you get? Like 79.9999 or something like that? Or 80? Yeah, you got about 80%. So that represents, if that means the new car is worth 80, or the second value is 80% of the first value. So how much did it go down? 20%. So when I did it, I took 23456 minus 18,765. That told me how much the car went down in value, and then divided it by this, and that gave me about 20% decrease. It was 19 with a whole bunch of numbers. All right, we're gonna save question D and E. Well, actually, we don't need to. How many of you have your calculators? Do most of you have your calculators today? All right, let's go ahead and do D and E then, because these are the ones where we have to have our calculator. D and E, these guys are known, I mean, they're so famous. There are certain problems that every pre-calculus and calculus student in the world do, because you're going to do these again in calculus class. You're doing differently in calculus class, but you're going to do these problems. This is called the box problem. And here is what I would like you to do. Do you have with you a piece of scrap paper, a piece of notebook paper? All right, get out a piece of notebook paper. We're gonna do a little arts and crafts. All right, hurry up, get out a piece of paper. And here's what I want you to do. I want you to take your piece of paper, and I want you to tear out, we don't have a ton of time to spend on this, so we don't need scissors and all of that. I want you to tear out a square from each corner of your paper, and try to make the squares about the same size. Do your best. We're tearing a square out of each corner. So everybody do this. Come on, get your piece of paper out. Piece of notebook paper. You're going to cut a square, tear a square out from each corner. So it ends up looking like this. I don't care how big the squares are, just get a square cut out from each corner. try to make them the same size for you. And it doesn't have to be perfect, so don't worry about, you know, making it absolutely perfect. Just get it ripped out. When you get, again, I'm trying to sort it careful and make squares. When you get your squares cut out, then I want you to fold the flaps up. Because when you cut the squares out, it created these flaps. Fold those up as neatly as you can. And lo and behold, it will form a box, right? Okay. So when you get your box made, hold it right up and let's look at some of these boxes. They're full of all the flaps. There we go. Okay, so I'm going to look particularly at Malcolm's box. I'm not making pleasure, I'm looking at it. Malcolm and I started with exactly the same size piece of paper. But my box looks different than Malcolm's box. Right? Why? Why did our boxes, why is your box a little bit
It wasn't a
different
perfect
shape?
square.
See, hers is a little bit different yet. What made the difference? How you tore it. The size of the corners that you cut out determined the shape of your box, right? Okay? Now, let's suppose I had been a really nice teacher and I had all of you make your box, and then I came around with a great big giant bag of M&Ms and I filled your box with M&Ms. Do you think the same number of M&Ms would fill everyone's box?
No.
Some of the boxes are going to hold more M&Ms than others, right? The problem, the famous problem in mathematics is, and in the real world, quite honestly, is if you're the manufacturer making these boxes, wouldn't you want to know what size a corner to cut out so the box would hold the most M&Ms?
Yeah.
I mean, if you're going to pay the same amount for the piece of paper and you're going to pay the same amount for the labor to make the box, then don't you want it to hold as much as it possibly can? So that's called maximizing the volume. This is a very famous, they're called optimization problems, and they happen in the real world all the time. You want your container, in this case it happens to be a box because that's the easiest, you want your container to hold the most it can. So, let's see if we can figure this out mathematically. Here's your piece of paper. It is 12 by 14. Now, yours was what, 8.5 by 11 or whatever size paper that was. Ours is going to be 12 by 14 for this problem. We are going to cut corners just like you did. We're going to cut corners. We don't know how big they are. We're going to call them X. We're cutting them out. Now, you've done this, so you can visualize that if I cut these out, these dotted lines will be the folds of the flaps coming up. That makes sense to you? Your job is to maximize the volume of that box. To maximize the volume. How do we find the volume of a box? What's the formula for volume of a rectangular solid?
Length times height times width.
Yep. Length times width times height. So let's go back to our, you use the one on the board, you use your piece of paper. The paper was originally, look where I'm pointing, this paper was originally 14 inches. But when I actually created the box, the length is not 14 inches. What is the length of that box? It was originally 14, But now this is the length of the box. What is that?
14 minus x.
14 minus
2x.
2x. Because you took an x off the top and the bottom. So your length is 14 minus 2x. Kids, the nice thing about these is they're all set up exactly the same way. What if the original paper had been 18 inches long? Then this would simply be 18 minus 2x, right? No matter what, it's going to be the original length minus 2x. Okay, what about the width? Now the original width was 12,
12 minus
but
2x.
this is the new width,
Yeah.
and that's 12 minus 2x. Now what about the height of the box? Think about it. When you folded up this flap, doesn't this become the height? And what is that? X. There is your equation. And the happy news is we don't need to multiply it out. We don't. This is it. We're done with writing the equation. That's the equation. So I'm going to back up and say this one more time. I don't care how big the paper is. If the paper had been 20 by 30, what would the volume be? 20 minus 2x, 30 minus 2x times x. Every time you do a box problem, this is going to be the setup. All right, so now we need the domain. This is our equation, so this is the answer to A. That's the volume. Now we need the domain. Once you go back to your piece of paper, if you say, Mrs. Ford, there's no radical and there's no fraction, so the domain is all real numbers. I will say no. No, this is a word problem, so there are some practical restrictions. Here's what I mean. If you tell me the domain is all real numbers, then you're saying x can be anything. Could x be 100? Could x be 100? Why? What? X can't be bigger than 12, Emma says. Because the whole paper is only 12 across, but she's only half right. Because if x were 10, Emma, if x were 10, could I take a 10 off this side and a 10 off this side? No. So actually, x can't be bigger than
0,
half of 12, which is 6. You could, if you had a 12-inch piece of paper, you could rip 6 off each side, right? But you wouldn't want to do that because then you wouldn't have a flap left. So we're going to say x has to be something less than 6.
Could it be less than or equal to?
No, because if it were equal to 6, what would happen?
0.
You wouldn't have a flap. Now, it also has to be bigger than 0. Because if you, obviously, x can't be a negative number. You cannot rip off negative 2 inches, right? So whatever x is, it's bigger than 0, it's positive, but in this case, it's less than 6. Now, Emma said, but it also has to be less than 7. Well, wait a minute. If I'm less than 6, won't I automatically be less than 7? So when you look for your restriction here, look at the smallest dimension. Because the smallest one is automatically going to take care of the bigger one. So let's come back to this piece of paper. This was our setup for our volume. What would our domain be here? Clearly, x has to be bigger than 0 and less than 10. Kids, it's less than half the smallest dimension. It's got to be half the smallest dimension, right? What? It's a 20 by 30 piece of paper, so the smallest dimension is 20,
Okay, yeah.
so that would be 10. All right, well, those of you that didn't have your calculators lucked out. We gotta have them tomorrow because we're gonna finish this problem and it's done on the calculator. We will do that